Okay, let's unpack this. We're diving deep today into something, something a lot of us interact with pretty regularly, especially if you've been playing around with the latest AI tools.
hmm
We're getting into the nitty-gritty of AI's reasoning ability. What does that actually look like right now?
Yeah, it's a topic that's definitely layered with expectation, isn't it? I mean, many people hoped AI would genuinely think, solve really tough problems like a human might.
Right. You feed it a complex scenario, maybe a puzzle or research question, and you kind of picture it churning away with pure logic.
Uh-huh.
But the actual experience, the real world results, have often felt, different. A bit awkward, maybe.
Yeah, awkward is a good word.
You ask it to reason, and sometimes you get these responses that are, I don't know, really verbose, or they sound plausible on the surface.
Plausible but hollow sometimes.
Exactly. But they somehow miss the core insight you are actually looking for. One source we looked at just nailed it, I thought. Called it a chattering assistant avoiding the core.
That description really resonates.
Mm.
And that disconnect, between the expectation and the reality, that's a key theme in the material we've gathered for today.
Okay.
So our mission for this deep dive is basically to explore a whole stack of sources, articles, some specific research, notes from user experiences, stuff that not only validates that feeling, but maybe more importantly, points towards where AI development is actually heading next.
And we're kicking off with some pretty fascinating concrete evidence. There's recent research out of Apple, of all places.
Yeah, Apple.
It gives us some hard data. It confirms that even the very latest, most advanced models are, struggling with what you might call true reasoning.
What that Apple research did is really telling, I think. They took these state-of-the-art models, names you'd probably recognize, like Claude 3.7, DeepSeek R1, some from OpenAI's O series.
The big players.
The big players, yeah. And they tested them with a series of reasoning puzzles.
Okay, so classic problem-solving tasks.
Yeah.
What did they actually find?
Well, this is the bit that's really surprising. When the problems got just slightly more complex,
Uh-huh.
the models didn't just fail to find the right answer more often. I mean, you might kind of expect that, right? Difficulty goes up, success rate goes down.
Sure, that makes sense.
But what was really striking was that they reduced their reasoning process.
Reduced it. You mean as the problems got harder, the AI actually did less thinking?
That's what the data suggests. The sources we read describe this as a kind of giving up thinking. As the complexity ramped up, demanding more steps or maybe deeper logic,
Yeah.
the sheer quantity of reasoning the machine even appeared to attempt actually went down.
Wow. That feels completely backwards. You'd expect a system built for intelligence to sort of lean in when things get tough, right? To expand its search or try harder logic.
It does seem totally counterintuitive. And maybe the most revealing detail from that research, this reduction happened even within defined token limits.
So it wasn't like it just ran out of space to type.
Exactly. It wasn't a limitation of output lengths. The models themselves seemed to internally kind of curtail their reasoning effort.
Huh. So this Apple research, and then you couple it with those user experiences, that feeling that the AI isn't quite getting the core, it really points to something fundamental about current LLMs, doesn't it?
It really forces us to look under the hood at what these models are actually built to do.
Yeah.
And the sources we looked at, they repeatedly emphasize that current LLMs are, at their core, predictive machines.
Predictive. Okay, but predictive in what sense? Like just predicting the next word in a sentence? How does that even look like reasoning?
Well, that's the key distinction, isn't it? They are incredibly sophisticated, yes, but at predicting language patterns, patterns they learn from the massive data sets they were trained on.
Okay.
They don't genuinely understand meaning in a conceptual way. And they don't construct truly new logic from first principles.
Yeah.
What looks like reasoning, what feels like understanding,
Yeah.
is ultimately, as the sources put it, a simulation or an imitation of thought. It's built on recognizing and reproducing patterns, not actual comprehension.
And I guess that simulation starts to pour down pretty quickly when you push it into areas that need genuine, deep expertise.
Absolutely. Think about highly complex, specialized fields, biology, medicine, cutting-edge physics, maybe some niche legal areas. You can ask the AI a question that requires really deep, subtle knowledge.
And the AI can spit out something that sounds incredibly knowledgeable, right? One source used that phrase, glamorous explanations, plausible logic.
Exactly that. On the surface, it's fluent, it uses all the right jargon, it builds arguments that seem logical. But, and this is the crucial part, anyone with real expertise in that field can usually tell pretty quickly
So what?
that the foundation is weak, the knowledge is shallow, and the suggested approaches are often, well, impractical or sometimes just flat out wrong.
Right. It's like getting a book report from someone who, only read the blurb on the back cover. They know the words, but don't actually grasp the substance.
That analogy actually comes up in the sources, like a student who just skimmed the textbook.
Okay.
They can use the jargon, piece together plausible sentences because they've seen those patterns before, but they lack that deep conceptual understanding needed to actually apply the knowledge or reason through a genuinely novel problem in that domain.
And this limitation sort of loops back to that user perception we talked about. When you enable those features that are marketed as reasoning,
Yeah,
the output might get longer, sure, and the response time increases, but you're often still left with that feeling, that sense that the AI is acting like they know a lot, but not hitting the core.
and that perception is why, according to the material we read, many users just don't rely on those dedicated reasoning functions very often, or maybe don't even use them at all.
The effort just doesn't seem worth the payoff yet.
The effort to utility ratio just isn't quite there. It feels, like one source suggested, a bit like getting the latest iPhone, always new but not necessarily needed for the actual task you're trying to accomplish.
That's a good analogy.
And, recognizing this limitation is actually really critical because it seems to be pushing the field toward a different path forward, a potentially much more effective one.
Okay.
The sources are pretty clear. Trying to rely on this sort of cost-ineffective simulated reasoning, that's not the answer.
All right, so if trying to make the AI magically think like us isn't really panning out, what is the direction? Where do we go?
The answer, according to the material we've been digging into, lies not in making these big foundation models spontaneously reason better on their own, but in reconfiguring existing foundation models precisely for the purpose you actually need to achieve.
Reconfiguring them, how do you do that? What does that mean in practice?
It involves what the sources are calling designing sophisticated agents. So instead of one giant monolithic model trying to do everything,
Right.
you design specific components or agents within the AI system. Each one is tailored to perform a very particular task that contributes to the overall problem-solving process.
Okay, can you give us a picture of that? What does that look like?
Well, a prime example that came up was the Google AI co-scientist concept. And this goes way beyond just writing a better prompt for, ChatGPT or something.
Okay, keep going.
It means designing multiple distinct AI agents. So you might have one agent specifically designed to, say, efficiently search and understand scientific literature. Another one designed to formulate testable hypotheses based on that literature.
Oh, okay.
And maybe a third designed to analyze experimental results or verify those hypotheses against new data.
And these different agents, they work together, interact somehow.
That's the crucial part. They are designed to collaborate.
Right.
And you combine this multi-agent structure with robust systems like retrieval augmented generation R or other literature-based learning approaches.
To make sure they have the deep knowledge they need.
Exactly. Ensuring they have access to the deep, specific domain knowledge required for the task.
Ah, okay, I think I'm getting it. So you're giving the AI access to tons of relevant information. That's the RAG part, maybe. And then instead of just hoping it figures things out, you're building a structured team of AI components.
A team. Yeah, that's a good way to put it.
And each member of the team is specifically engineered to process that information in a very methodical way, perhaps mimicking how a human expert or a scientist would actually approach the problem step by step.
Precisely. The whole goal shifts. It moves away from hoping the AI will spontaneously figure out how to reason like a human expert,
Right.
towards engineering a system where these specialized agents are designed to perform the specific functions required for expert-level problem solving. The aim is to maximize domain expertise and deliver results that aren't just plausible sounding, but are actually accurate, reliable, and truly user-fitted to the specific task at hand.
This feels like a really fundamental flip in how we think about AI problem solving. It's not just telling the AI, think about X anymore.
It's a really profound shift, I think. The core idea is that before the machine can solve a complex problem reliably, it's actually essential to design the problem-solving structure itself first.
Design the structure.
Yeah, you map out the logical steps, the necessary processes, the methodology required to tackle that specific kind of problem. Then you essentially imprint that structure itself onto the machine.
No.
By designing and configuring these specialized agents and defining exactly how they interact and collaborate.
And that's where the real utility, the genuine power comes in.
That seems to be the argument. That's where you move beyond that awkward imitation of thought we talked about earlier. Only when the human designs the effective thinking process and structures it for the machine can you achieve genuine effective collaboration. The machine then executes that design structure, but with incredible speed and scale.
And does this approach line up with how the sources see the bigger picture, like the broader stages of AGI development unfolding?
It seems to fit quite neatly, actually. The sources we looked at describe AGI development as potentially moving through distinct stages. The era we've been in focused on stage 2, which is where that generalized reasoning in LLMs has been the main focus that's described as kind of setting. Foundational, yes, but not the end state.
So we're moving on, transitioning.
Exactly. We're seen as being at an inflection point right now, shifting strongly towards stage 3.
Yeah.
And stage 3 is defined explicitly as the sophisticated design of agents.
Okay.
The idea is that this stage, building these structured agent-based systems, is necessary before we can really reach stage 4. And stage 4 is where AI might genuinely take on an innovator role, contributing truly novel solutions and creative insights.
So the next big leap isn't just making the general LLMs think harder or better in some vague sense,
Probably not.
but rather it's about taking the sophisticated structures of human thought processes.
Yes, exactly. Breaking down those human-centered, domain-specific ways of thinking like the scientific method or legal argumentation or the workflows for medical diagnosis, designing those structures meticulously and then building them into machines using these specialized collaborating agents. That's what seems to pave the way for that truly innovative stage 4 role.
And we're seeing this already.
The industry is definitely showing signs of this move. You see development of highly specialized agents for domains like medicine or law, precisely because that's where this structured design approach is delivering practical, reliable value today.
Okay, so this whole shift away from simulated reasoning towards designed agent structures, it leads to a really interesting, maybe the most crucial question for AI development going forward, doesn't it?
It absolutely does, and the sources articulate it really nicely, I think. It's the shift away from that initial, maybe less effective approach of simply ordering the AI to think,
Yeah.
to asking this new core question: how can we share the structure of my thinking with the machine?
Wow, that completely reframes the challenge. It puts the onus back on the human's understanding, doesn't it?
Yeah.
Understanding the problem deeply and designing the solution process.
It really highlights that the path to more powerful and useful AI
Yeah.
might not be about trying to replicate human consciousness or spontaneous reasoning inside a black box.
Mm-hmm.
Not right now, anyway.
Mm.
Instead, the real value, the near-term progress, seems to come from our ability to clearly articulate our best problem-solving structures.
Our methods, our logic.
Our methods, exactly. And then empower the machine to execute those structures quickly, accurately, and at massive scale through these carefully designed agents. Finding effective ways to transfer our methodological thinking into machine-executable structures, that's seen as the pathway closer to achieving something like true AGI, or at least much more capable AI.
So, okay, to sort of bring this deep dive toward a close then, we've explored how recent research, like that Apple study, and also just widespread user experience, confirms the limitations of current AI's generalized reasoning.
How it often simulates thought but can fall short in depth and reliability, especially when things get complex or require real domain expertise.
Right. And we've seen how this reality is pushing a pretty significant shift in the field, moving away from hoping for spontaneous AI thinking
Towards the deliberate design of sophisticated collaborative AI agent systems. Systems that actually embody structured thinking processes, often mirroring proven human methods, like, say, the scientific method.
Which means the human role isn't just about asking the questions anymore or feeding it data. It's increasingly about being the architect, right? The architect of the AI's whole approach to solving the problem, designing the very framework the machine operates within.
Yeah, it's about leveraging the machine's incredible strength, its speed, its data processing power, its pattern matching capabilities, but doing that by providing it with the intelligent structure it needs to apply those strengths effectively, rather than just hoping it'll somehow develop that structure all on its own.
Which really leaves you, the listener, with this powerful thought from the source material to mull over. What incredible new possibilities might open up when we shift our focus, when we stop expecting AI to somehow figure out how to think like us, and instead get really good at intelligently designing systems where AI can powerfully execute the structures of our most effective thinking. What becomes possible then?